Alright, now let's go into transformations. There's four types of transformations that we'll concern ourselves with, and that first one is reflections. So a reflection is generally referred to as a flip. So you're flipping about a line, and that line is called the reflection line. The reflection line is the perpendicular of the segments that connect the pre-image and the image points. So if you have 2 points, then the line reflection is going to be perpendicular and bisect the segment that connects those 2 points. There are some special lines of reflection on the coordinate plane, the x-axis, y-axis, and y equals x. If you're reflecting across the x-axis, then xy turns into x negative y. If you're reflecting across the y-axis, then xy turns into negative xy. And if you're reflecting across the line y equals x, xy turns into yx. Next, we're going to talk about translations. So a translation can be described as a slide. So you're just sliding the pre-image to the image. Now the pre-image moves to the image along a translation vector, which is the distance and direction from the pre-image to the image point. So this line right here would be the translation vector. And if the translation vector is AB, then to move a point from xy to its new image, then you just add A and B to the x and y coordinates. Next we have rotations. A rotation is basically just a counterclockwise turn, unless specifically stated to be clockwise, about a point. And that point is called the center of rotation. So the angle of rotation is made by the pre-image point, the image point, and the center of rotation. And the angle of rotation varies depending on how much you rotate it. So this would be an example of the angle of rotation. There are some special angles of rotation in a coordinate plane. 90 degrees, 180 degrees, and 270 degrees. These are all counterclockwise, by the way. If you rotate 90 degrees counterclockwise, then xy turns into negative yx. If you rotate 180 degrees counterclockwise, then xy turns into negative x negative y. And if you rotate 270 degrees counterclockwise, then xy turns into y negative x. Next, we're going to talk about dilations, which are basically just a change in the size of a figure. So, a figure is dilated around a center point, which is the endpoint of an array that contains the pre-image and the image points. The scale factor is the amount that the pre-image is dilated by in order to get the final image. The distance from the center point to the pre-image point times k, or the scale factor, is equal to the distance from the center point to the image point. So if you dilate in a coordinate plane with scale factor k, then xy just simply turns into kx, ky. You just multiply each the x and y coordinate by the scale factor. This, of course, assumes that the origin is the center of dilation. A composite transformation is when you perform multiple transformations in a row. Now, onto symmetry. So symmetry is when a transformation maps a figure onto itself. So there is two-dimensional and three-dimensional symmetry. Some types of two-dimensional symmetry are point symmetry, when a 180-degree rotation maps a figure onto itself, such as this curve. Line symmetry, when reflecting something about a line reflects the image onto itself, like this isosceles triangle. Rotational symmetry, where rotating a figure around a center maps it onto itself, like this equilateral triangle. Now, rotational symmetry has order and magnitude. Order is the number of times that it can be mapped onto itself, and magnitude is the smallest angle of rotation needed for one turn about the center. You can find the magnitude by dividing 360 degrees by the order. So for example, this equilateral triangle here has an order of 3 since it can be turned 3 times, and a magnitude of 120, or 360 divided by 3. Then we have translational symmetry, which is when you have a figure that is composed of many congruent parts, such that you can translate one part and it will map it onto itself. So like this structure made of a lot of squares, you could translate the squares over and it map it onto another square. Then we have three-dimensional symmetry, so I'll just borrow some space over here. In three-dimensional symmetry, we have solids now instead of just flat figures. So one type of three-dimensional symmetry is plane symmetry, which is basically line symmetry in 3 dimensions. You reflecting around a plane maps a figure onto itself. Like a prism, you can reflect about this plane and you'll get the same half on the other side. Another type is axis symmetry. In axis symmetry, rotation about an axis maps a figure onto itself. This has an order and magnitude as well. So for example, this rectangular prism would have an order of 4 and a magnitude of 90 degrees.